Hi everyone, at the end of this video, you'd be able to solve a set of linear equations or linear system using the Gauss elimination method. The process starts with a set of linear equations or the linear system, which contains a set of variables. In this case, we have x, y, and z, and given a set of linear equations, we are going to transform this into an augmented matrix. You will see here that the augmented matrix doesn't contain the variable. Instead, it contains all of the coefficients. This vertical bar separates the left-hand side of the equation from the right-hand side of the equation. Next, we would be converting the augmented matrix into the row echelon form using some elementary row operation. And finally, we would calculate the solution from the row echelon matrix using the backward substitution method. Let's look at the first step in detail. So we have a set of linear equations, and to convert the linear system into our augmented matrix, we would only consider the coefficients of the linear equations. So we have here 4 minus 8 and 1 on our left hand side. We would separate the left hand side from the right hand side with a vertical bar. We have minus 21. 4 minus 1, 1, 7. Minus 2, 1, 5, and 15. In step number 2, we would be reducing the augmented matrix into the row echelon form using elementary row operations. Now, if we look at the row echelon form closely, we would see that the matrix here is an upper triangular matrix, where this is the leading diagonal and the values underneath the leading diagonal are zeros. Now let's start performing the elementary row operation to reduce these values to zeros. We would first consider the second row. Now how would 4 be 0? Yes, by multiplying the first row with negative 4 and then adding the first row to the second row, we get this value as 0. So the formula would be negative of A21 divided by A11 multiplied by the first row plus with the second row. This gives us the new row 2. So let's perform the operation. The first row stays the same, so it's 4 minus 8, 1, negative 21. negative A21 divided by A11 would be negative 4 over 4, which gives us negative 1. So the value here is simply negative 1. Okay, so we have negative 4 plus 4 as 0. Negative multiplied by negative 8 becomes positive 8. And positive 8 minus 1 would be 7. So negative row 1, right? Negative of 1 plus row 2 plus 1 becomes 0. And again here, negative of negative 21, which is positive 21, plus 7 gives us 28. And that would be the row reduction for the second row. Now let's reduce the value minus 2 here to 0. How do we do that? The formula is almost the same as the second row. We take negative of A31 here divided by the coefficient of 1, 1, which is A11, multiplied by the first row plus the third row. And this gives us the new third row. So in this case, negative A31 divided by A11 would be negative of negative 2 divided by 4, which is half. So the value here would be half. We would multiply half with the first row and add it to the third row. So this gives us 2 minus 2 as 0. Half times minus 8 would be minus 4 plus 1 gives us minus 3. Half multiplied by 1 is half, plus 5 would give us 5.5. Half multiplied by negative 21 would give us negative 21 over 2 plus 15 gives us 9 over 2 or 4.5. But we do not stop here because the row echelon form contains 3 zeros for a 3 by 3 matrix. So we need to do another transformation to convert minus 3 into 0. I would rewrite this matrix. To ease the calculation, I would change 5.5 to 11 over 2 and 4.5 to 9 over 2. Okay, so the row operation would be for the third row. And we would add the second row with the third row because the value A21 and value A31 here are 0. And when we add a 0 with 0, we get 0. So we get our new row 3 by taking the negative of A32 dividing it with A, 2, 2, multiplying it with the second row, and adding it to the third row. So negative of A32 divided by A22 would be 3/7. So I need a bigger space and I would write it here. The new matrix. The first two rows will be the same. So I'm just going to copy the first two rows. Okay, now the third row, A32 would be 3 divided by A22 divided by 7 gives us 3/7. So now I'm going to multiply 3/7 with the second row. And this gives me 3/7 multiplied by 0 would be 0 plus 0 is 0. 3/7 multiplied by 7 gives me 3. 3 minus 3 is 0. And 3/7 multiplied by 0 is 0. Plus 11/2 is 11/2. 3/7 multiplied by 28 gives us 12 plus 9/2 gives us 16.5. And this would be the row echelon form. Step number 3, which is also the final step, would be converting the row echelon form to our solution. And this part is quite easy to do. We would now multiply the coefficient with the variables again. So we had x, y, and z. And we are starting with the last row. So we have here 5.5 z equals to 16.5. And 5.5 is also 11/2. 16.5 is also 33/2. This gives z as 33/11, which is also 3. Next, we would consider the second row, the third row, the second row. So from the second row, we have 7 multiplied by y, 7y plus z multiplied by 0 is simply 0, equals to 28. Now y gives us 4. Let's consider the first row. Row number 1. We have 4x minus 8y plus z equals to negative 21. We would substitute the values of y and z into this equation. And we have 4x minus 8 multiplied by 4 would be 32 plus 3 equals to negative 21. So negative 32 plus 3 gives us negative 29. When we bring it to the right hand side, we would have negative 21 plus 29, which is 8. So 4x equals to 8. gives us x as 2. And then we could write the solution as this. We have x as 2, y as 4, and z as 3. So whenever you perform the Gauss elimination method, I would recommend that you check your solution using your calculator during your test. I only have the Casio FX570MS, and I'm going to show you how to check your answers using the calculator. You would first press mode 3 times and then choose equation. Next, because the solution is a 3 by 1 matrix and we have 3 unknowns, which are x, y, and z, we would choose 3 as the number of unknowns. And then enter the values of A1, A2, A3, and up to D3. So A1 would be 4, B1 would be negative 8, C1 would be 1, D1 would be negative 21, press equal, and then A2 would be 4, equal, B2 would be negative 1, up to D3, which is 15. And once you press equal after D3, you would get your answer, x as 2, y as 4, and z as 3. So you can try this out on your own, and you can pause the video to find the answer before we continue with another example. Okay, in our practice session, we have a different set of linear equations, and I provided the solution for you so that you could actually try this one out on your own and check the solution. So you may pause the video, try the question out by yourself using the Gauss elimination method to solve the problem, and check the answers with me. So in the first step, we would convert the linear equations into the augmented matrix. 2, 4, 6, negative 12, 2, negative 3, negative 4, 15, 3, 4, 5, negative 8. Next, we would perform the row operation to reduce the augmented matrix into the row echelon form. So the first row stays the same. The new row 2 would be negative of 2 divided by 2, which is negative 1 multiplied by row 1 plus row 2. So we have negative 1 multiplied by row 1. Negative 2 plus 2 would be 0. Negative 4 minus 3 would be negative 7. Negative 6 minus 4, negative 10. Positive 12 plus 15 gives us 27. And now, the elementary row operation for row 3. So the new row 3 would be negative of 3 divided by 2. Row 1 plus row 3. Negative 3 over 2 multiplied by 2 gives us negative 3 plus 3 is 0. Negative 3 over 2 multiplied by 4 plus 4 gives us negative 2. And the next value is negative 4 and 10. So I'm going to copy this matrix. To reduce this value to 0, we would be taking negative of negative 2 divided by negative 7, which gives us negative 2 over 7 multiplied by row 2 plus row 3. This would be our new row 3. The first two rows remain. And this value would be 0. Negative 2 over 7 multiplied by the second row plus the third row. So negative 2 over 7 multiplied by negative 10 plus negative 4 gives us negative 1 over 7. Performing the same operation, we would get the value 2 over 7 here. And finally, we would solve the problem using the back substitution method. Multiply this with the first variable, which is x1. This would be x2, the second column, and the third column, x3. So the backward substitution method gives us, we start with the third row, negative 1 over 7 or negative 8 over 7 multiplied with x3 is 2 over 7 or 16 over 7. And so x3 is equals to negative 2. Let's consider the second row. Negative 7x2 minus 10x3. So we plug in the value of x3, negative 2, equals to 27. Negative 10 multiplied by negative 2 gives us 20. And when we bring it here, it becomes negative 20. So 27 minus 20 would be 7. So negative 7x2 equals to 7, which means x2 is equals to negative 1. Finally, let's consider the first row. We have 2x1 plus 4. I would plug in the value of x2 as minus 1 plus 6, and x3 was negative 2 equals to negative 12. And with some calculation, you would get x1 as 2. So there you go, the solution for your practice session question. And finally, we have another set of questions, another set of linear equations. look at this set closely and pause the video and try to think of a solution. So the answer is the linear system has no solution. Why is it so? When you look at the first linear equation here and the third linear equation here, they are inconsistent. So this is because the linear system is inconsistent. It is inconsistent. Thank you very much for your attention. I hope that I made Gauss elimination method easy for you. And if you have any questions, you could ask me during the tutorial session next week. So I'll see you then.